All right, we're at 100. This is definitely a milestone here. And what are we doing over here? We're going to talk about the contents. Right, you need to read that stuff. You need to understand the examples, and then you get busy on the exercises to reinforce what you learned in the content and the examples. My name is Ron Bannon. This is a draft version of my adaptation of Webster Wells' Advanced Course in Algebra. This PDF document that you're witnessing over here is for the Prison Mathematics Project participants only. All right. This document will be published at a future date, and for teachers and students looking at this document, if you're interested in getting a copy of it, please reach out to me. My email address is Bannon, that's B as in boy, the @ symbol, NNON.US. All right? So I'm going to kind of, scroll. I'm not going to read it to you, but kind of paraphrase. Logarithm number any base. Well, I think we, for the most part, we concentrate on base 10 and base E. E is Euler's number, and that's called natural logarithm, and base 10 is called common. All right? But the bottom line is it's a really short section, and it looks like they're just simply going back over the base change formula. So what I want to do is I want to write it down for you. All right? So they want the logarithm of 0.3. I'll write that down for you. They want the log of 0.3, right? But they want the base 7, all right? I'm going to say I don't know what that is, all right? Now, someone says, I don't even remember the base change formula. You scrolled by it so quickly. Well, you don't need to remember it. You need to rewrite this as an exponential. I'll do that for you. We'll get the base change formula, by the way, as we do it. This is going to be 0.3 would equal 7 to the x. Then I would take log of both sides. Now, whether you take a natural log or base 10 doesn't matter. I'm going to use base 10, though. So log base 10 of 0.3 would be, let's see, x log base 10 of 7. And then to solve for x, pretty simple. What do you get? Log base 10, 0.3 over log base 10 of 7. And that's a base change formula. That's right over here. Again, I would recommend use a computer to do the computation. If you prefer, you can use natural logs. Let me go through that with you. So you'd have 0.3 equals 7 to the x. Take the natural log of both sides. Natural log 0.3. Yes, you calculate that button too. This would be x natural log of 7. And then what are you going to do? X, pretty simple. It's going to be the natural log of 0.3 divided by the natural log of 7. It's still going to give you the same exact answer. No surprise there. All right, now let's look at this one over here. I'm going to read it to you. It says, find the logarithm 128. I'll write that down for you. But now there's a base 16. And I'm going to say, I don't know what it is. All right, I still want to think about it. And as I'm thinking about it, I'm seeing numbers I'm familiar with. And what does this translate to? Some exponential, right? So 128 equals 16 to the x. Well, it's going to be 2 to the 7th. Again, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128. Hope you've been keeping count. I did 7 factors of 2. And 16 is 2 to the 4th. This is 2 to the 4x. So now what I know, it looks like a familiar problem. I know that the exponents have to be the same. It's 2 to the power, 2 to the power. Well, that means 7 equals 4x. I'll write that down for you. Oops. What's x? 7/4. All right? I want to point out this answer is listed over here for you. However, let's say we want to use the base change formula. Well, we just went through it. So I think I can probably write the base change formula down pretty quickly. So log base 16 of 128. If I'm using natural logs, it's going to be natural log of 128 over the natural log of 16. Or if you're using base 10, it's going to be log 128 over the log of 16. All right, let me point out where these things are. That's right here. And I don't think I put I didn't put base E down. But anyway, you do it in a calculator, you get 7/4. all right? If you want to. What's 7 quarters? 7 quarters is 1 3/4. On a calculator, it may appear to be 1.75, right? That's kind of familiar. All right, what do you get to? It's a very short section, exercises. What do you do in the exercises? Work through the problems. It's basically a base change formula problem. And there's, some problems, say how difficult they look. They look pretty standard, pretty straightforward. And again, I say in Wells times, when I say straightforward, they're actually more difficult because they had to use tables to figure out the logs. We don't need to do that though, all right? By inspection, I want to point out what inspection means. Wells often says that you should be able to look at things and know their answers. I'm not of the opinion, by the way, but if they say it's by inspection, you can do it without a calculator. So I'm going to write this over here for you. Log base 49, 1/7. I'm going to say I don't know what it is, so it's 1/7 equals 49 to the x. Well, this is going to be 7 to the minus 1, and 49 is actually 7 squared, so it's 7 to the 2x. What does that mean? Minus 1 equals 2x. And what does that mean? X equals minus 1/2. So the answer would be minus 1/2. Now again, Wells of the opinion that maybe some of that stuff can go on in your head. There's nothing wrong with that. If you can do your head, it's a great thing. Same thing, this one over here, by inspection. I'm not saying do it in your head. Then you get to the SAGE code. Boy, this is really repetitive, isn't it? What's SAGE? Computer algebra system. It's a CAS, computer algebra system. I'm going to say it's free, which means it's open source software. Go here. That's the website that stores the software. And there's a bunch of help systems there and forums, yada, yada, yada. You can either download it, web-based application, type this stuff in over here. When you're typing it in, though, you may not know what you're typing in, and that does happen. So I would play around with it, all right? Now, for example, you notice there's 2 numbers over here, right? So what I would do is I'd play around. So someone says, what do you mean play around? Try something. Try log, and try, let's say if you put down 10 and 100 here, right? Now, I'm not saying that this is true, but, maybe this is a log base 10, maybe it's log base 100. You should know the difference, by the way, all right? So let's say I want to do this over here, log, and I was doing, let's say I think the base is 2, right? And what would it be over here? I'd say 8, right? So I want to look at this one over here. I just want to discuss it with you a little bit, all right? And so I don't know what these things mean. That's why you type it in. You type it in so you get meaning out of it, all right? We want you to get meaning out of it. So that n over there is giving an approximate answer. When I don't use that n, it's getting the exact answer over here. So play around with SAGE. Just play around with it. Okay, the key here, though, is that I'm not too interested in this computer algebra system at this point, but you should be thinking about moving forward. What I'm really interested in is, can you do the prior problems? And we're hoping you can, right? If you think there's any errors, though, and there could be, just please reach out to me. My name is Bannon. My email address is also Bannon. That's B as in boy, the @ symbol, NNON.US. All right? By reporting errors, you're not only helping yourself, but you're helping the community at large. Thank you for your time.